So that's essentially what I'm trying to do here, and that's what I think 90% people have a problem with is that once they have half an idea, they go to coding.
Hmm.
And that's why they feel like, oh, what the fuck? I was thinking through this. Why can't I get the solution? It's like, have you thought of all the cases? And the easiest way to think of all the cases isn't by writing code, is by just drawing a fucking diagram on the board. Hey, what's up?
Everything is good. How are you?
Hey, I'm doing good. Your name looks familiar. Have I coached you before?
No, but yeah, I made some edits to the Google documents. I commented the video. Maybe that's why.
Ah, gotcha. Yeah. So, tell me a little bit about yourself. Where are you in the interview process? What are you hoping to get out? Where do you think, you're messing up?
Okay. So like I am a software engineer at the moment, and I've been at it for like 6 years, 6.5,
Mm-hmm.
and like yeah, maybe last year I realized I would like to maybe to change job. And I started preparing last year. It was some sporadical, really not connected, some random competitive programming problems. Was
Mm.
not no system at all. But then somehow I got an interview with Microsoft in March,
Mm-hmm.
and I actually passed it. So it was a bit strange experience. It was not what I expected, because like there was this online assessment test. It was not difficult, and then on the on-site there was almost zero technical issues. There was no whiteboarding problems. We were just talking. Like, so it was felt pretty strange. But the position was in Ireland, in Dublin,
Uh,
and I live in Germany, and it was exactly the start of this COVID-19, and the borders were closed.
oh,
And basically, I said no, because it was super strange situation, was not clear. They couldn't explain me well when I'm actually going to start. They said, yeah, maybe you can start from Germany, then we will see. Actually, I didn't like that. And also, I must say, I had two interviews pending with Facebook and Amazon, and I thought, okay, maybe I will clear that because it was so easy with Microsoft.
mm-hmm.
But it was wrong assumptions. I kind of failed both of them. So at Amazon, I went pretty far. I passed this phone screen, and
Mm-hmm.
then I was invited on site. And they didn't provide any feedback, so I failed the on site. But what I feel it was maybe not even problem related. It was more system design and behavioral. And with Facebook, I didn't pass the phone screening. It was ridiculous because kind of there were two problems. I solved the first one was like I know finding some minimum maximum. It was not that hard. The second one, I'm sure I knew it, and I'm sure I knew the optimal solution. It was like finding the kth largest element or something. And I said, yeah, I saw it. And the interviewer said, yeah, then tell me the solution. How would you solve it? Just in words. And I said, yeah, I would take a heap, and just I will put elements, and I will push when it's too many elements. And then he said, yeah, okay, so it's n log n. Now solve it in O n. And I was totally blocked because I kind of learned by heart. I knew the problem from lead code, and I couldn't. He said, yeah, what if there are like not so many frequencies or something? Like, can you now solve it in linear time? And really, it's terrible. I think it's the result of learning problems by heart. I just memorized probably the solution with a heap. I
Mm.
couldn't adapt, and he started to explain to me, and the conceptually he wrote like for me everything. He almost coded it for me. Yeah, but of course then
So
I
kth
failed.
largest element in a list, or kth largest element in like a binary tree?
No, it was in a list, yeah.
Okay, I see. Hmm. Give me a second. Let me get some paper.
Yep.
Hmm. Okay, so it seems like you have. Yeah. So it seems like you're practicing improperly. At least that's based on what you just told me.
Hmm.
Hmm. And okay, let's. I'm trying to figure out where to aim because I feel like Okay. Let me tell you something. With people with leak code problems like that, with what you just described, it's purely a mechanical skill, and there's almost nothing that I can do on that front. Only because, um, it's again, it's mechanical. It's something that you practice, and nothing I say or do is going to be able to replace like hours and hours of proper hard work. Now, I can
Hmm.
tell you how to think differently, like, oh, what was the decision that you made doing this problem that messed you up? But if you are the type of person who just goes off of memorizing leak code solutions, then that's something I really can't help. Does that make sense?
Yes.
So, like, I guess I'm trying to figure out the best way to help you. So what have you been doing recently to kind of get over this, like the memorized solution thing?
Yeah, like I read your paper, the Git good. I mean, I
Mm-hmm.
find it amazing. Yeah,
Mm-hmm.
and like I also, and now I have to say I have like also a coach, a paid coach from Google,
Mm-hmm. Yeah.
and I've done like maybe 3 or 4 sessions, not that much, but basically, yeah, he also says similar things. So like he tries to push me into the direction like not remembering the exact solutions, but more like patterns or ideas. I mean, this course, Grokking Decoding Interview, right? It's, yeah, I think this is what I would like to go, to move from where I am now. And like really this idea that you need to, like what you also write, I think, like that you just need to translate the problem into the set of how do you call them, preconditions or something, or requirements,
Mm-hmm.
and then you define the output. So these are, I think, two my main points. First, I want to kind of to learn how to decompose the problem, how to convert it into this conceptual form that I can then apply algorithms. And
Mm-hmm.
second, I kind of try to now build the connections between the problems, because before I didn't know that kind of there are so many connections. Like,
Mm-hmm.
yeah, like with a cyclic sort, for example. But I mean, I solved the problem, missing number or something, when the array is in sequential, right? I solved it with some kind of XOR, and I was happy, but I had no clue it could be connected. Like, yeah, what if there are like more missing numbers? What if, and all of that stuff, I kind of missed that. And now I want to connect the components,
I see, I see. So you need practice breaking down the problem and then like recognizing what you need to do.
Right.
Okay.
If you want, I can quickly send you a link to my GitHub. How kind of, if you will have time for this.
Yeah, let's do that after. I think okay, so
Okay. Okay.
practice breaking down the problem. Okay. Hmm. So we basically you have a paid coach at Google who says exactly the same thing I did.
Nothing there. I think the idea is pretty similar. Like decompose the problem, work on patterns, like this stuff. Yeah.
Yeah, so that's pretty much what it all boils down to. So I need help breaking down problems and working through them. Mm, how on a scale of 1 to 10, how comfortable are you with patterns in general?
Well, I think, I don't know, 7. Well,
Mm,
maybe it's now. Let's say 6 now.
mm, mm.
Weakest point, because I know you like this topic, so I thought, okay,
Okay.
cyclic sort is kind of really a blind spot for me.
Okay.
So I
I think
started
I know
doing
what. I think
the
this
cyclic
one will
sort.
actually be pretty good for you
Just
then.
solved a couple of easy
Hold up.
problems
Okay.
there.
So if you that's what you need to do, then did you spend the entire weekend working on what's it called, coding interviews and prom?
Right.
Oh, you
Yes.
did.
Yeah, I was working on this grokking, and I finished the sliding window, and then I thought, okay, what is my weakest point? Because I know you like this topic, so I thought, okay, cyclic sort is kind of really a blind spot for me. So I started doing the cyclic sort,
Mm-hmm.
just solved a couple of easy problems there.
No, that makes sense. But between you and me, I'm gonna say I've never seen like cycle sort actually be used. I feel like it's such a nuanced pattern,
Yeah,
and I mean,
I
yes,
see.
it can be helpful, but I only use it as like an example, but just because
Got
it's
it.
like so easy to understand very, very quickly, and I needed to like cite some example to lay out my point in these documents.
Mm-hmm. Mm-hmm.
So personally, I think it's okay to learn, especially it's just like practice for you to break down a problem. So I think it's fine. But I would not expect it in an interview, just to be clear.
Mm-hmm.
Okay. Cool. Send you the link.
Yeah, I see it. Yeah. Yeah, got it.
Okay, let me know if you've seen this problem before. So, given a binary search tree, write a function to find the kth smallest element in it.
Mm-hmm.
So, in other words, if I gave you a tree that kind of looked like this and asked you to find the first smallest element, we're going to return out 1 because it's the first smallest in this tree.
Mm-hmm.
Do you
I
need
see.
another example, or you think you understand?
I think I understand. Like, yes, I think I've seen this problem in this elements of programming interviews. I remember the brute force solution, but not sure about the optimal solution.
Let's
So
let's so good, perfect. You understand the naive solution. Now let's see if you can break it down to find the optimal one.
just I will just
Like
talk out.
don't do it based off memory. Just start from scratch.
Yeah, so from scratch, like the easiest way is we can do an in-order traversal, and we can save the results into an array, and then after that we just set the pointer to the end of the array and decrement it until we reach k. It's kind of the brute force, and yeah, it uses additional space, order of n. Now there is a way to solve it optimally. Let me see, just with your example, let me just, I will make my own example to figure it out. Let's see, so if k is 2, the second largest number is here is 2. All right. I think, wait, I think we still can take advantage of some kind of traversal. Let's see. Yes, look, what if we have some, we can still use the in-order traversal, which will guarantee that the numbers will be in the sorted order, but then we have a second pointer, and then we just need somehow to make sure that the distance between the, let's say, the fast pointer, and in the slow pointer will be exactly k. Let me think. I think it could work if implemented correctly, but yes, let me think a bit more. Okay, for example, let's say k is 2. We start with 3, and another traversal, so we move first to the left, we reach 1, and already we set the slow pointer to 3, so let me write it here, so slow will be here, and fast, yeah, okay, I will destroy it because nice structure, okay, like this. I think just one letter. Yeah, 1 is enough, I think. Just the letter. Okay. And then we do another iteration of the in order. We reach fast. Will be here, slow. Will be here. Okay, so from here, how do we know that we have found it? Yeah, because we reached the lowest element, right? At 2, when the fast pointer knows this is the end, right? So we are guaranteed it's the smallest element there because both children are null. And as if and the slope pointer will be pointing correctly.
Mm-hmm.
So I think conceptually, yeah, it could work. Yeah. So then in this case, the time complexity will be linear, and we will not need any additional space, so it will be constant.
Mm-hmm.
So that's basically my approach. Would you like me to start coding it?
Okay, so okay. I see what you're trying to do. You have a slope pointer, fast pointer, and then you separate the distance, but of them by k. Is that right?
Right.
Okay. Let's see. Well, let's see what happened. Go ahead.
Right.
What do you
So,
think? Well, let's first start off. What was the time space complexity of your naive solution, and what's the time space complexity of this solution? If you're saying you want the optimal solution.
so in the original one, the time complexity will be linear order of n, because
Mm-hmm.
this is just we need to iterate through the tree only, and the space complexity will be n amount of elements
Mm-hmm.
in the tree. And in the second one, the time complexity will be linear, so again, order of n, and the space complexity will be constant.
Okay. Okay. Yeah. Sounds fair. Good. Go ahead
Good.
and code it up.
Okay, so let's see. Find k smallest, right? And fine. I'll copy this. So we need input of integers. So I can assume it's integers, right?
Mm-hmm.
Good. And we also need k. Good. All right. Yeah, we can do some edge cases validations later.
Okay.
Let me see. Like from here. Yeah, we need some recursive function for the in-order traversal. Private in order. Right, yeah. Let's see this. Yeah, I assumed it was in the format of a tree, but actually it's an array. So we can think quickly.
Mm-hmm. Oh, go ahead. I mean,
Yeah,
I could give it to you as a tree as well, if you really wanted to. But
I think would be easy otherwise.
yeah, go ahead. I think it's fair for me to do that.
Okay, so I'll just write it here that it will be a tree node.
Mm-hmm.
Right, because here then I will have.
Yeah, I'm not trying to be an asshole about you. Oh, yeah, you need to be able to treat an array like a tree node.
Yeah, otherwise I will just write a separate function maybe to convert it to a tree node, to a tree.
Yeah.
Or I will have to deal with pointers. I don't know what it's about. Okay, we need we'll have here, we'll have some kind of, we'll start here. Let's see. Now, yeah, the in order itself is, let's say, not that difficult. But how can I do this with pointers? This is trickier. Although, what if I, let's say, pass here a second pointer? So instead of calling it root, I will call it fast. And the second one will be slow. And let me see. Now I need. Okay, if I start here from 3, I say another traversal. So at first I pass this route, and the slow pointer is null. Then I need to wait to figure it out that now it's time to set the slow pointer. How can I do that? Maybe I can track the how many nodes the fast pointer has moved on. Okay, so it's gonna work. Okay, let's test on this example. On my own example, 3. Let's say. Okay, 3 is the fast pointer that moves here. I increment the variable. Now the distance is 1. We will know that this second pointer should be 3, but we already lost it because we moved in to the next level of recursion. Yeah, it's a bit tricky to implement, but I can always have the reference to the root, right? Because the slow pointer will always start with the root. That's, I think, this could work. Yeah, I think let's just pass the root here. Maybe I can reduce the amount of arguments later. 3 now, we'll keep the root. And then here we also need, it's gonna grow a bit. So we need k. We also need to know kind of depth. I don't want to call it like count of nodes that we have traversed.
Okay.
Somehow, I think it kind of. Let me think. Am I starting with the right place? Because it looks like maybe I should start tracking it when I reached the smallest element. Yeah, I think that's the time.
Well, the thing is that you have a fast pointer that is traversing, and then a slow pointer that follows up after you've seen whatever number of nodes, and you need to know when that occurs.
Right.
And you've elected to use recursion.
Right.
Is there, and it seems like you I mean, you can do this, but do you think there might be a way that would decrease the work?
Let's see. Reduce the work. No, by reducing the work, you mean there will be like fewer operations or fewer variables?
Here's the thing: you're carrying around those variables, right? The count, and you have to constantly keep updating it while you recurse through.
Yeah.
And after every traverse, every single time you look at a node, you have to keep updating it. I mean, you can do it, and there is a way of doing it, but it seems like your idea is kind of half baked. Like you don't know how to complete it. So I'm just trying to think. Well, do you want to make your life easier by doing it a different way?
No, I got your point. Yeah.
Like same idea. Like what you have is fine. The basic idea. I'm just talking about the change the implementation.
Yeah, I think if I think carefully, we don't really need the root. We will just initially we will set the slow to root, and we will only start updating slow pointer when we see that we have reached this k number. So I think that we can get rid of it in the first place, yeah.
Mm-hmm.
The other ones, yeah, theoretically I can have only one variable, so I will have just k, and then I will just keep decrementing it. And when I reach 0, I will know now it's the time for the slow pointer. Yeah, I think it's also not necessary. So I will just leave the k.
Okay.
Okay. Let's see. From here, first we will need to check. Okay, we'll need to check if we have reached. No, wait. We don't want to check if we have reached the last element. We want to check first. Is it the time that the slow pointer must start? So how do we check it? If k equals 0, and then we'll need to do something with a slow node. So what do we do with it? We need to call one step of in order traversal. Okay, how do we do this? We check if slow left is not null, then we move it there. Slow left, and if it's otherwise, I don't expect it to be a leaf, so otherwise we will move it. To the right. Then actually it's not really, it's maybe one of the base cases, but the important base case is when we achieve the leaf, when the fast pointer achieves the leaf, we need to check this also. So if fast left equals null and fast right equals null, yeah, this is where we're gonna stop. Okay, if we achieve this point with the fast pointer, then we know that now we can return the kth smallest element. So in this case, we will just return slow, and kind of we expect some value, and we'll update the signature.
Wait, hold up. What are you doing here?
I'm kind of trying to code the base case when we reach these, like the leaf with this fast pointer, and this is basically when we return the slow pointer, yeah, right? Because we know the fast pointer has already reached the smallest element. Now we are ready to return the kth smallest element.
Okay. All right. I want to see where you go with this.
All right. Okay, the issue is that if I say that I want to return an integer, then the whole function needs to return this integer. Okay, let's leave it so far like this. Maybe I will reconsider this. All right, this was the first base case. Then we have this condition. If k is 0, we will start doing this looks actually not that good. No, this part where I try to move this stall pointer. Okay, what is the next step? Yeah, first we'll always move left, left, left. Flip is 0, we'll move right. Okay, assuming this is gonna work, whatever. How can we? No, if we have to return in this example, let's say we want to find the fourth smallest number, then we need to wait for the slope pointer to go up in the binary tree. With this code, it will not go up. Yeah, it's kind of not clear.
Mm-hmm.
Yeah. Probably, yeah, let's just speculate a bit. What if I had a not recursive but iterative in order, and then at least I would had a stack of elements which I need to process next. That would be easier. And at least I know. Okay, just let me think.
All right, let me slow you down a bit.
Yeah.
So, describe to me. I know what you're trying to do, but I want you to try walking through another example. Just generate another example of a tree, and then let's actually try and work through that. Let's take a step back.
Okay.
So let's suppose I gave you a balanced tree instead. I'm going to type here. So, oops. So what if I, instead of, let's wipe this, I gave you, yeah, let's say I gave you 2, but then, let's suppose it takes floats for now, just so that way I don't have to, redraw, because I don't have, this is not whiteboard. So let's say I have 1.5 here. And then I said, so then, yeah, the second largest element would actually be 1.5, wouldn't it?
Right. The second smallest, yeah.
Yeah. So then, but then if I also made this, trying to make us one where it's not the leaf. But then if I change it to something like, if I get left pointer here, and I made 0 here, what do you think which one is your solution?
The second will be 1.
So in the examples that we've been using, the solution has been a leaf. In this one, it's not a leaf. So my question to you is, how does that change? Knowing this, how does that change your code or your thought process?
Oh, yeah. Well, looks like. Let me see. It's probably was flawed logic that What was it? And if I was trying to move those pointers until I reach the smallest.
I think I think the pointer idea is actually fine. Like I think it's
Yeah,
actually
yeah.
pretty good. It's just a question of, well, how do you want to do it? Like how you're gonna write it?
Mm-hmm. I'm just looking at this example with floats, and in that case, where will be my slow pointer? It will be, I guess it would be 2, yeah, and then the fast will be here. And then if I kind of think I can return to this point, it's wrong, yeah, because the answer is 1.5. So I think what I need to change is that I need to do the in-order traversal with the fast pointer, and then when I reach the base case, so when I reach 1.5, this is the time I should, I think, set the slow pointer. So I need to do it when we come back from this recursion stack. I think this is the correction. How to implement it? Let me explain a bit better. So we reach this one, we reach 1.5. We know it's the smallest element. Yeah, we are guaranteed that. All right. So the slow pointer in the beginning will, okay, we reached it. We set slow and fast here. And then we come back from the call and fast lands here at 2. And the slow, we don't move it because it's less, in this case, K will be, wait, in this case, no, we will not move it, but in the K will become 0 and we will know that the answer is 1.5. Okay, this is the idea. Yeah. So as I said, the correction is I should not have started with the root, but I should have started with the smallest element. Okay. Shall I try to fix that in the code?
You could.
Good, let's see. All right, we'll start from the beginning. So when the naming is, I think it's fine. Okay, when we reach the end, this doesn't make sense anymore. We'll say here that slow equals fast. And then we will move out. Let's see here. This was, now it's not necessary. So this is the base case. If fast left, now then we move left. It's just basically the meat of the in-order traversal. And then we will say in order fast left, slow. Okay, and fast to right. Fast, right, slow, okay. And basically we're done. With the in-order traversal, let's see now this part with the case smallest. We need to check if slow pointer is not null, because then we can start modifying k. If slow is not null, then yeah, we will decrement k. And if k becomes 0, then we know we're pointing the case smallest number. Return slow value. Now we also have to return something here in the end. And this is the first point, and also I need to move the slow pointer also somehow. Okay, about the return value, I would not worry too much. I can have some variable here, like a global, the class variable, but the instance variable. But here, how do we move the slow pointer if it's not null? Let's go back to the example. We are here. Yeah, I think I forgot it's, yeah, the slow pointer stays the same. This is the fast pointer that we want to return. But no. Wait, let's finish that. Output 0.5.
Seems like you're stuck.
Yeah.
I mean, you're 32 minutes in. I mean, do you want to keep trying, or do you want to just call it? Because I don't think there's a way to unstuck yourself right now.
No, in 3 minutes especially not.
I mean, no, in a normal interview, I would have given you another 10 minutes to try and unstuck yourself. But, yeah, I don't think, based on the way you're thinking right now, I don't think it would be worth the time to do it.
I agree.
Right. I'll stop the timer and then let's review it. Okay. I'm going to share my screen with you.
Okay.
Do you need like water or something?
No, I think I'm good.
Okay. Okay. Cool. Okay. So let's start off with this. So the beginning of the interview, I think went fine. In fact, I was pretty surprised like how quickly you got it. So like if I go here, you were basically talking about, oh, here's your naive. You remember seeing it on LeetCode, and that you knew what the naive solution was. And then you decided, and then you came up with this slow fast pointer. So I'm very curious. Like, how did you think of this?
Yeah.
I mean, I
What
kind of
what they
know, but
mean?
I want to hear you say it.
What they mean exactly?
I'm
How do I
trying to
know?
figure out like there's so let explain the reasoning and then I'll tell you what I'm thinking. Because if I tell you what I'm thinking, that's going to influence what you're telling me. If that
Okay,
makes sense.
okay. So I think I saw this problem in this element of programming interview.
Mm-hmm.
Somehow, I just from the memory remember this problem. If I'm not wrong, so I just remember the brute force very clearly, like by heart. Kind of, I remember that well.
Mm-hmm.
And then with the pointers, I think it was not from the memory. I guess I just somehow something maybe I saw something similar, but I cannot remember exactly. But I think I saw this pattern like 2 pointers in a tree. It was similar with this lowest common ancestor, something like this. So somehow it occurred to me, okay, what if we take 2 pointers?
Oh,
And
I
this,
see, I see. Yeah, I'm literally looking at the book right now, and then it's like I got this problem somewhere else. But oh shit, it's actually is here. Hold up, I don't see what solution they use. But
like,
essentially, what the point I was trying to get at here is, um, I was wondering if you were trying to link it to like the two pointer usage that you use for arrays. Do you
oh,
remember? Are you familiar with that pattern?
yeah, more or less. If you mean those like start and end pointer, then you do something, or with like in cycles, so they're also like those 2 pointers.
Yeah, essentially that's what I was going for. So let me take a look at like what solution they use. Da da da. Because it might be different
Okay,
from the one I'm using.
I'm also checking the book now. Let's see. So,
Oh yeah, okay, I see what they're doing. Yeah, okay, no, they're basically what they're doing is they return back the size of the subtree.
shit. Okay.
Yeah, but for me, because you went with this slow, let's focus on the implementation that you have here.
Mm-hmm.
I think based because I'm not trying to get you to copy solutions. I'm trying to get you to think.
Mm-hmm.
So let's commit ourselves to this, even if it's like, um, terrible or whatever. So here, you seems like you have a pretty good idea in your head at around 6 minutes and 20 seconds, and then you start typing code. So ordinarily, I would be having the heebie-jeebies if I'm in your shoes because I'm writing code and I have some idea. But
Mm-hmm.
okay, let me. How do I put this? What do you think the least important part of the interview is?
Like typing the solution.
Yeah, pretty much the coding, right?
Yeah.
Because if you have the design, if you have the examples, then the code is really easy to freaking write, right? But instead, you just start off here with at 6 minutes, you're starting to write code. And I'm like, okay, well, you have some idea of what you want to do, but I don't know if you have fully thought it out. And it turns out you really did not. Like, if we keep going, we go up to 30 minutes and you don't really write any meaningful code. So this already tells me that you have a half-baked idea before you even write code. That's probably where your biggest problem is.
Mm-hmm.
I would say like right there, instantly you probably just killed your interview right there. Even if you solved it, I probably would not have given you full points unless you wrote it perfectly. Like right off the bat, unless you wrote it perfectly, I would not give you full points. Only because, well, this design aspect is pretty goddamn important when it comes to software engineering. Like you know this as a right?
All right.
So the fact that you skip through it is sending me a signal like, wait, what the fuck? Is this guy like never really thought through his code before he wrote it before? So that's that is the big red flag I get right there. So
Mm-hmm.
around 11 minutes, you're trying to figure out how to set up your fast and slow pointers. So the hint I was trying to give here was that okay, well you could do recursion. There's two, what are the two ways to traverse a tree? Like not in order pre-order. What are the two ways that you can perform it in order traversal?
Yeah, like recursively and in place,
Yep. So the
or iteratively. I mean, yeah,
yeah, like iteratively with a.
stack.
Mhm. So that was the hint I was trying to give you here. It's like, well, you don't seem to have a clear idea of how it works recursively. So maybe what you can do is instead do it iteratively, like with a stack. Because with a stack, you
Mm-hmm.
can keep track of the path, which is kind of like what your solution is here, right?
Mm-hmm.
Because with the in order traversal, you tend to lose a lot of the information. At least this is the way I would think of it. Um, so, but then you decide, oh well, you interpret it as, oh well, what if I can just remove all that information? So you end up just committing yourself to it, fine. But ultimately, what I want to get to is that at 24 minutes, I finally say, okay, well, let's take a step back and generate some examples. And it seems like once I showed you those examples, you finally realized how hung up you were on the first one. Like trying to identify this leaf. Does that make sense?
Mm-hmm. Yeah.
So you basically committed yourself to one example and one example only without ever thinking about how to cover all your cases. And that basically I would say, killed your thinking, killed the rest of the interview. So if we look at the timer, the fact that it took basically from 6 minutes to 24 minutes, that's 18 minutes just to get here, just to figure out, hey, I need to do more examples. That should already tell you something about your thought process. And if we were to eliminate those 18 minutes, do you think you would have had like what 28 minutes left in the interview? Do you think you could have properly coded up a solution?
Not really.
Okay. So then let's actually go through. Let's go through here. So I'm gonna write. I'm gonna write what I would do here. So I understand that I need to have a fast and slow pointer here,
Mm-hmm.
but I also recognize that up to a point I'm going to need to remember the path that I took,
All
right?
right.
So which means that in my mind there is no real way of how do I describe it? Getting rid of remembering what I did, because in either case, in order traversal, let's say I do this recursively, then I do a visit left right just by definition, right? So
Right.
in other words, I need to be able to remember the nodes that I visited once I recurse into the next step. So there's no way of really getting around that. So for me, I would say if my k counter does not equal 0, just going by what you said, where every single time we traverse with the lead pointer, we decrease. So let me write that up here. So as we traverse with lead pointer, then we will decrease k. We only start the slow pointer once k is equal to 0. You would agree, right?
Yeah.
Or k equals to 1, just to keep parity. And so once I visit, then if my k counter doesn't equal to 1, then I am forced to remember that node. because that is the node that I will be feeding to the slow pointer. So in other words, store the node that I have visited in a global list, just for the sake of ease. So this already tells me that right here, that the size of the memory usage, which is of size k, because once I traverse and adjust, then I move back up the leading pointer, right?
Right.
So, and then once I have gone through it, and well, let's say my k is equal to 2, right? Then I need to store in 2 nodes into the list, and then as I traverse through with the lead pointer, then I need to adjust then I need to shift the slow pointer to this or the slow nodes list, so to say. Does that make sense so far?
Yeah.
So this is basically how I would approach your solution, and then once I realize, oh shit, this is my case, I would still need to keep memory of case size for this. Then I would immediately go back and rethink this. So going back to my examples, I would just say, oh well, okay, I would walk through this one 3, and my output is 2. So I would say 3, 1, and say, okay, well, I can't really select. Well, I'm gonna start at the root, right? I can. It's gonna be at 3. And I haven't found the second smallest element yet. I haven't found the smallest element yet. So I'm gonna go to 1. Now I can start moving my slow pointer to 3. But that means that I need to remember 3 to begin with.
Mm-hmm.
So this is at least the way I would start thinking about my solution. Now, now trying to get to the optimal solution usually involves some kind of optimization, and you keep optimizing until you realize that there is a limiting factor or limiting characteristic. In this case, our limiting characteristic. So let me rephrase that. So our runtime is of order n, right?
Right.
Because we have to visit every single node, and then our time space complexity, our space complexity, right now is of order k. Before it used to be order n, with keeping the list that is in our naive solution, and now we've reached order k. So, what do you think is easier to manipulate?
Like, easier to manipulate. You mean, what do you mean exactly?
So, out of these two, the runtime or space complexity,
Oh,
which do you think is easier to improve?
yeah, the second one should be this kind of closer already to maybe to our goal, which will be like constant space.
Yeah, constant space, or even no space if possible. But obviously, there is going to be some constant space because we do need to store some information. So right now, we have to go back to the drawing board here. So this should already tell you that your traversal is absolutely fine, but that you need to be able to store the information differently. So what does this tell us? That if the fast and slow pointers force us into remembering the path, then we can't do it, because those two go hand in hand. So therefore, we cannot use fast slow pointer if we want to achieve order 1. So far, I have already spent 7 minutes on this.
Mm.
And I have already laid out what the pseudocode is. I'm just gonna do a. I'm gonna start off with a normal in-order traversal, and then I'm just gonna remember a list of size k, and then I will just, and then as I iterate, I'm gonna have my fast pointer feed elements into the list, and then evict them, and then my slow pointer is essentially the head of that list.
Mm-hmm.
And I've already identified that if I want to improve my runtime, that I cannot do this. This would be the wrong solution. In 7 minutes.
Would you actually type it in the interview or just talk about it?
No, I would type it actually. You know why?
Okay. Why?
Because I don't have to remember it. Because it's already documented up here. It's already written. Then all I have to really do is just follow it. And plus, it's like what's easier for me to move an English sentence or to move a chunk of code? Which one's
Yeah.
easier?
Yeah, looks like pseudocode is easier, right?
Yeah, like if I say, oh well, if I want to be more atomic about this, visit and then here I could say recurse left and right. Look how easy that was. It was like 5 seconds of work.
Mm-hmm.
But if I did that with your code, then I'd be like, oh well, shit. Okay, I have to remember this. I have to remember. Is it going to break all the other shit that I wrote?
Yeah.
But if I do it with like just fragments, then it's very easy, and the interviewer still understands what the fuck I'm doing. So this is the way I see it. It's just breaking like what decisions do these solutions force me into? Like, if I take this solution, what other baggage am I going to be holding on to? And the baggage here is the list. So, which means that this is not going to work. So then the question is, how do we achieve the what's it called, the solution that the book is talking about? So, going back to it, the insight that it would need to be had is that we need to store the size of the left subtree and the right subtree. So if we look here, then in the left subtree number of elements, and then right subtree number of elements, and if we have some, if the index we are looking for is greater than left, number of left elements less than number of right elements, it's at visit. Otherwise, if less than number of left elements, go to left. Otherwise go to right. This is essentially the gist of what they're talking about. Now, you're probably wondering, how the hell do I get this insight when I'm in the interview? So that is actually a very good question, and I would actually have to look at the problem a little bit more. Give me 2 minutes, because I'm just trying to follow my own train of thought.
Okay.
So I see that I can... So if I were to, I'm trying to do it from your position. If I got to fast and slow pointer. So I know I'm married to the in-order traversal, and so with the in-order traversal, I have the option of passing back information. The question is, what kind of information do I want to pass back up? So if I need to find the kth smallest, then I know everything in the left side. Now everything in the left side is smaller than my current index, my current node, which means that I must be the kth index. Let's say I index if there are I items on the left-hand side. So that's my insight right there, if that makes sense. Was that a little hand wavy for you, or do you need me to go deeper?
Let me read it once again.
So this is what this is what would start me here. Now the question is, how do I translate I to K?
Mm-hmm.
So let me see how I would translate I to K. I'm looking for the second smallest. Yeah, if I go through this, so let me then it's not immediately obvious to me, so I'm gonna walk through an example. So I'm starting at 3, right? So here I'm gonna recurse here, and I see that left side has 3 elements, right side has 1, so it must be in left hand side. Here I'm at 1, so then left side has 0 elements, right side has 2. So I'm gonna say must be right hand side here. The left side has 1 element, right side has 0, so therefore must be I plus, therefore must be self. So my theory right now is it must be I plus 1. Let me try this again. The structure is similar, so it must be right hand side. But so left hand side has 0 element, right hand side has 0 element, so must be self. So so the last factor is whether or not I is if there is a right side node. So I've covered it when it's like left side, middle, when it's a leaf. Now the other 2 cases I need to cover are right hand side only, and when it is a parent with 2 children. And once I solve that, then I've covered all my bases, and then I can go ahead and code it. Does that make sense?
Mm-hmm.
Because there's only 4 possible situations that a node can be in. That it's either a leaf, it has one child on left side, 1 child on right side, or it's a full tree, or it's got 2 children. Now, after that, so I've handled all these cases. Now I know I'm kind of hand waving here, but it's just for time's sake, and I'll let you do it. But after that, I'm gonna be thinking, well, what if my K is out of bounds? Bounds for K. What happens in that situation? So let's say we're going back to this example. What happens if I have K is equal to 10? So I'm gonna walk through this. I'm gonna walk through this example. Left side has 3 elements. The right side has 1. So left side has 3 elements, or 2 elements. Right side has 1. So it's bigger than left plus self plus 1 plus right. Invalid. So that's basically my condition, is if the sum of these elements is bigger, then I will call it invalid. Now, why does this work? Because an element cannot be between this left and left plus 1, right?
Mm-hmm.
Or right and right plus 1. Because you're dealing with an integer amount of nodes. So you're guaranteed to at least track you're guaranteed to at least catch it. So, like for instance, in this case, I have my possible numbers 2, 3, 2, 1, and then 1. So, which other words, the numbers I'm dealing with, if I traverse to the left, are 2, 3. And if I traverse to the right, it's going to be 2, 2. So, there's no blind spots in this, if that makes sense. So, once I've built the argument, then I start coding. Because now that I've covered all my base cases, I've covered my ass. There's nothing that can really slide through. Would you agree?
Yes.
So I mean, So I've covered every single one of those possible situations, and then if I really need to double check, I'll just generate another example for one of these cases. But then that's basically how I would drive a solution, and I think it should be pretty close to the way the book does it. I'm curious now. I actually haven't read it.
Wouldn't you be afraid that you will run out of time with writing this kind of explanation, and then you will be left with no time to code it?
Not really. It would take me once you actually understand it, then it's actually pretty easy to code, right? Because you don't have to think about the idea anymore. You just have to figure out, how do I traverse to the left-hand side? How do I traverse to the right-hand side? In fact, let's just, it should really only take you only 5 minutes to do it. You know how to write a traversal. So how long does it take for you to write traversal?
Yeah, that's
Yeah, it takes you a minute, right?
Yeah, exactly.
And then now you just have the traversal handle these base cases. Right? So in fact, you know what? Let me illustrate my point. I'll just do it right now. So tree node n. How long does it take for me to do a traversal? So then, traverse n dot left, traverse n dot right, and then if n dot, and then the base case is if n is equal to null.
Exactly.
How fast was that? Yeah, and then after that, you just need to be able to start building off of it, using these cases, right? So then, so then traversal, we're gonna expect back an int because we want to keep track of the size. So if n is equal to null, return 0, because that's the size of the tree. So int val equals tree. And so let's start with the here. So left side has 1 element, right has 0, therefore self must be. So we need to pass in some kind of k. K. So then left side has 1 element, right side has 0, therefore self must be 1. So if if k is less than val, so then we know it must be inside of the the left subtree. And left. And then so which would be return traverse.n. But there's a problem. Is that we have a size, and then we need to be able to return something else, right? So I would argue that I would need some kind of state variable. So the state variable would be int size, comma, node if found. Something like that, and then return dot val dot node. And then we'll call this state. So this is how I organically would grow my solution. And so, but you understand the point here is that it only takes me very, very little time to iterate over that case and then build my solution. And it's pretty fast, right? I've only been doing this for 2-3 minutes, and I'm doing this off the top of my head while I'm trying to explain it.
Yeah, I see.
And I don't even know if I'm pretty sure this is pretty close to what the actual solution is. Like, oh, they do it iteratively. Hmm. No, that makes sense. But hopefully you get the point.
Yeah. Yeah, I think so. Yeah, because I think I just once had an experience when I was talking and talking, and then the interviewer said, "Okay, can you now start coding?" I think that's like kind of messed me up a bit. Yeah.
No, no, no. Usually we just like to ask you to start coding if we think you have fully understood and fleshed out the idea. That's usually an okay sign. Don't take it
Mm,
badly. Um,
okay.
I would say if your design is super solid, that's already 80% of the job right there.
Mm-hmm.
And then after that is the last 20%. Can you express that idea in code?
Mm-hmm. So by design, you mean like conceptually solving it, right? And like proving that it's gonna work. Like, is it that what you mean by design?
Absolutely, yes. Like, going back here, I'm just like, huh, I have some idea of how it works, like right here, but I don't know how exactly that would work in the actual example. I and so here's my example. My examples are meant to test that idea and develop it. Does that make sense?
Mm-hmm. Yes.
So that's essentially what I'm trying to do here, and that's what I think 90% people have a problem with is that once they have half an idea, they go to coding.
Mm-hmm.
And that's why they feel like, oh, what the fuck? I was thinking through this. Why can't I get the solution? It's like, have you thought of all the cases? And the easiest way to think of all the cases isn't by writing code, it's by just drawing a fucking diagram on the board.
Mm-hmm.
And you notice here, like, how I've covered every single case that I could possibly run into? Like,
Yep.
in fact, like, if I really wanted to and the interviewer wasn't convinced, because I was definitely only taking, um, the note I was taking what's it called just the leaves here. I could just say, oh, let me abstract this into a note into a subtree tree with q elements instead, and then I would just go off that. But ultimately, that is up to the interviewer. But if the interviewer thinks I have a pretty good idea of what I want to do or agrees and tells me to code, then I'm going to say fuck it. I'm just going to start writing it. But you saw how quick. My point here is that you saw how quickly I was able to do it. It's like probably like 7 minutes for writing the design, and then like maybe 5 minutes so far for coding or some shit while talking.
Yeah.
It's like 13 minutes. Like that's way less than the 18 minutes that you spent. And you know what? If I was in an actual interview, maybe I could have gotten it in like 25, 30 minutes. And I didn't even really understand like what I didn't really understand what the lead code solution, not lead code, but the EPI solution was. But I'll send you this recording. But essentially, what I'm trying to do is get you to understand what are the signs that I need to look for in order to progress. So the first solution that you achieved, I think, was actually fine to propose something like this. But it's just that you need to understand what dimensions that you're operating under. And I think one of the things that people really misunderstand about the coding interview is that it's not a college exam. It's an efficiency game. How efficient are you at approaching things, and how efficient is your solution? And so, how do we improve efficiency? By improving this.
Yes.
And what's the most efficient way of trying to improve it? Well, go for the obvious ways of actually improving it. So it's not obvious that we can improve this runtime. So let's just go after the space complexity. And how do I improve my space complexity? By not remembering shit. Okay, so then I do need to remember some information, but I can only remember like one piece of information. What is that one piece of information? So once I traverse, I need to be able to send something back. That's what this O of 1 is telling me. Send something back in the left subtree. Well, what the hell am I sending back? Like, well, I can send back the node if I found it, but if I didn't find it, then what else can I send back? And that's basically the train of thought that I take back. take in order to get to the optimal solution.
Mm-hmm.
And I think you can talk to your Google coach about this. But this idea of maximizing your efficiency in both your approach and in the algorithm is basically what I think the coding interview boils down to.
Yeah. Yeah, I see.
So I definitely would try to do this problem on my own if I were you. Like, and not
Mm-hmm.
do it recursively, just do it organically. I mean, not do it like the way they do it in the book. Do it organically, following this train of thought.
Mm-hmm.
The solution might not look the exact same, but if you can prove that it does the exact same thing, then I think you are on a good path.
Mm-hmm.
Hopefully, this all makes sense.
Yeah, that makes sense.
Any questions so far?
No, I think I kind of get it. Yeah,
Mm.
it just you wrote also in that document
Mm-hmm.
like about those. Remember, there were like few steps, right? And you say like the first three or two are the highest priority for a coding interview.
Mm-hmm.
I think kind of I think it kind of makes sense when I think about it. Yeah, just when I apply what you have just said to that
Mm-hmm.
pattern, yeah.
Because it's very
Even,
like if we follow the steps, it's very clear you understand what the problem is asking. You understand that very very clearly.
yeah.
The next step is, do you understand what it's supposed to look like? And I remember, like, when I wrote in there, there's like three steps in between the understanding the problem and actually writing code that all involve actually understanding the examples and understanding all the possible cases you can run into.
Mm-hmm.
So, yeah, definitely would try to go forward with my leak code problem practice if I were you, keeping all that in mind. And actually, you know what? I noticed you signed up for another session later on. Send the
Yeah.
doc to the interviewer and show him this document and see what he thinks. I'm very curious.
You mean this Google Doc, right? Just a link to
Yeah,
it.
yeah. This Google Doc, I just explained to him briefly how I approached the solution, how I was thinking. I'm very curious to see what he thinks.
Okay.